Welcome everybody to Build the Roof First. That is yes, it's not building the roof first, I removed the ing before I got here. Anyhow, my name is Brendon Page. I'm a team lead at Chilisoft. And if you guys have been to any of the other talks before this one today, which I'm sure you haven't just been hanging around in the swag center, also known as the LARPer. There's a book to give away. I have no clue how I'm going to give it away. It may be really good question at the end or something. No, you cannot have the book, Josh. No. Okay, cool. So I'm just going to get straight into it. I like to always start off with a question that tests people's arm functionality, in case I want to ask a question during the course of this talk, and I get no hands. And you guys should actually be answering it yes, but you just, I don't know, don't have enough blood flow. So who are you? How do you identify yourself? If you're in a casual conversation with somebody else, no social pressure, how do you identify yourself? I've put a few options up there. I personally say a developer, I like to say a developer. So hands up, developers. I suppose this conference does say software developer. But any guys say like engineers? Okay, so we have a few engineers. Okay, Josh, engineer. Okay, about 4 in the room who call themselves engineers. Architects, do we have fancy people? Oh, we have some fancy people. Young people at heart. And then trendy people, craftsmen? Craftsmen? No, you guys take your stuff seriously. I'm just... Okay, cool. Okay, so it looks like just about everybody put a hand up, so I'm going to trust that your arms work. Cool. Well, I just want to start with a brief overview of this talk. If there's one thing that I want to try to do today, is to challenge your thinking about the order in which you write software. Now, I'm not telling you to not do your whiteboard sessions. I'm not telling you to no longer do requirements analysis. I'm not telling you to do any of that. Today, this talk is not about that. However, if you want to, you can take the stuff I've applied here. I'm giving you here and apply it to those aspects. But today, think about when you get to your keyboard. Sorry, architects, you're just going to have to remember back a little bit. But when you get to your keyboard and you go, okay, I'm about to write some code. Apply this thinking that I'm going to go through today, because I think it's the easiest and quickest place you can start. Then you can let it permeate out. Cool. So I would love to start with a story that during the course of this talk kind of just dropped a ton of bricks on me, and I realized, wow, this is an amazing story. It's about the Wright brothers. Now, I somehow managed to avoid history classes, most of them, except for standard 6. It's, you know how old I am, still using standards, not grades. But in case somebody here was like me and they skipped the history classes, the Wright brothers were the first people to actually successfully build a manned aircraft. Okay, that with the motor. They were not the first, and this is the interesting part of the story. For those who are wondering where I got the story from, it was not from Wikipedia. It was from Robert Greene's book on mastery. And he tells it from a very interesting perspective that I haven't heard before, so it was a very powerful story. The Wright brothers weren't the first trying to do this. In fact, they weren't even close to the first. There was a government-funded ship engineer, like, water, sea ships, that had been going at it for ages before they started even. And they obviously didn't get to the goal first, right? The Wright brothers are the ones that have been written into history. The Wright brothers came from a bicycle background. They worked, you can correct me using Wikipedia if I'm wrong, or owned a bicycle shop, and they would, they were obsessed with tweaking and getting bicycles to be better, So they didn't come from a classic engineering background. However, these guys still managed to somehow, without a year or so a head start, beat these people with a background in doing engineering, right? That's quite interesting. And why? Why? Well, the shipbuilders, the person the engineer that was building ships, they were approaching the problem through the ship as an aircraft. Okay, so that was their frame of reference. That was structuring their thought. That was their metaphor. Whereas the Wright brothers, they had the bicycle as an aircraft metaphor. So you could say airship or air bicycle, but that just sounds ridiculous, so I didn't put it there. But more seriously, those different perspectives were structuring their thought. And I've recently read a book called, for this talk, by the way, thank you, Donnie, if you're in the audience, called Metaphors We Live By. And in that book, there's one brilliant quote that really hit home about this talk. It's that the variability, and I'm going to read it because I don't want to screw it up, the variability that allows us to comprehend one concept in terms of another will necessarily hide aspects of that concept, and I take it as a bit of a warning. So the shipbuilders were using a metaphor that hid something from them. And one very important aspect, it hid something about stability. The thing that they were actually stuck on that was taking a lot of time was stability. They were trying to create a craft that was inherently stable. You know, ships are inherently stable. Well, the ships they designed. I know you get catamarans and all sorts of other interesting ones, but the ships, you know, the cargo ships that they designed. Whereas the Wright brothers come from a bicycle background. So they're just like, well, bicycles aren't stable. We just give the control, the instability to the pilot. So naturally, the Wright brothers just did that. That option wasn't hidden from them. So are we the shipbuilders? Do you think anything is being hidden from us? Let's test those arms. Yes? No? It's brave to say yes. I mean, like, we get paid a lot of money to do a character building, you know? Yeah. So I think we are. But before we can say, yes, there's something's being hidden, we have to ask ourselves, well, what metaphor is the primary metaphor of our industry? Now, I'm going to click next on the slide, and you might be completely outraged by the metaphor that I've chosen. I'll reason it through. That's fine. But it's important to note that it might actually not be your metaphor, and that's okay. You could still take what I've applied about metaphors and, you know, ask yourself the same questions. But if you accept it, you just kind of, I don't know. I'm not mentoring, I'm giving him spoon feeding you at this point. But it's a talk, so I kind of have to, right? So, oh, well, I kind of went over the slide already. Did you like the image? So it's the building metaphor. And if you question that, just ask yourselves, how do you talk to colleagues? What do you call yourself? Some people said architect before. Some people said engineer. Some people said develop, most people said developer. All those are just terms straight out of the building industry that borrow directly from the building industry. So I'm convinced that that's our primary metaphor, and I'm going to run with it. So what is it hiding? Is it hiding anything from us? You guys have already kind of agreed with me that it is. Well, about 10% of you put up your arms. The rest of you forgot how to use them, or just disagreed with me. I'm going to go with forgot how to use them, so that's cool. And to answer that question, I asked myself, well, are there any aspects of the that apply to the building metaphor that are not applicable to the software world? So they apply in the physical world, they don't apply in the software world. And I chose two. The two that I chose, one is obvious, and the other one, again, you might be completely outraged by, but we will work through it. So please don't leave at that point in time. You'll find me crying under there afterwards if you leave. I'm guilting you, I'm sorry. Okay, so my two are gravity. Whoever saw code fall off your screen? Or through the bottom of your file or something silly? Nah, there is no gravity in software development. And the second one is hard to change. And this is the outrage one, like, no, code is hard to change, guy. You cannot tell me it's not hard to change. Well, it is not hard to change. I go to the keyboard and go, and I changed it. Now, you're going to say, but it's not going to do the thing I wanted to do, so you did a meaningless change. And that's actually quite interesting, because change involves two things. The first is the physical act of changing. The second is the thinking behind that change in order to get the desired results. Now, in the building world, those two, the physical act is the hard part that requires a lot of energy. I've got a wall that's straight. It should be a corner. Okay, well, I know it should be a corner. Maybe I need to do the measurement, but like, that's the choice, you know? Now I have to go destroy it and then rebuild it. So the physical act, once the thinking's been done, is hard. The thinking is, granted, can be difficult, the bigger the building challenge, but then proportionately the act of actually doing it grows as well. You know, building the I don't know, some big tall skyscraper somewhere is a lot of planning, but it's a lot of work as well. Whereas in the software world, it's the other way around. Doing the change yourself is, there we go, it's done, whatever. I moved the wall in 5 seconds. But doing the thinking is really difficult. Arguably, I would agree, harder than in the real world. So those two are inverted. And I don't think we realize they're inverted, and therefore it's probably hiding something from us. Words are great. Because it's hiding something from us because we're still used to the actual change itself being hard. Okay. So let's move forward. Anybody still outraged about hard to change? Okay, now I'm going with the fact that you just agree with me and that your arms like, you know, and they haven't fallen off or anything. That's a good thing. Okay, and I would like to examine these two particular aspects using two well-defined terms. Now most people should already have a vague idea of what they are when I read them out: point of input and direction of execution. Because most of us say we write software in the room. Still a few arms weren't working. I'm going to just do a definition check because I don't want any misunderstanding. We're already working, and I'm busy talking about metaphors, so we're already in the realm of abstract. So I don't want misunderstanding for these two particular terms. So points of input. Any point at which data enters the system. Now, that can be an HTTP call. I've handily got images to remind me the list. A button click. That little funny sensor thing is actually a sound sensor, air pressure sensor, or a command line input. That's the point of input. All of them can be point of inputs, and you could have multiple points of inputs for a system, not only one. Or the command line, you only have one. Okay. This call stack that I have on the screen is going to be my friend, and hopefully it's going to be your friend. It is an inverted call stack, just because I didn't want to put certain things at the bottom for some strategic reasons. Ignore that. Okay, but quite simply, I'll just go through it quickly. Main, string args, it's where the main function in a console application. And then that calls a calculate function, which needs to find some data, so it calls a find function, which then goes and calls some load because it needs to load it from somewhere. I've intentionally kept it quite, sterile of detail because I don't want you to say, oh, you've misspelled the parameter. And I'm like, yeah, okay, that wasn't, no, stop looking there. Okay, so with regards to the point of input, whereabout is this? Let's see who's been listening and who wants the book. Which line is it on? I didn't give line numbers, but no, I can't ask you, Traveshan. Oh, Josh, you've outcircled me here, haven't you? You put your, oh, wait, hold on a second. Yes, Christina, right? Okay. Main, yes. You can come up and get the book afterwards. Well done. Sorry. Yes, Josh.
What about programs on load, depending on where that's loading data from across it?
That's actually an interesting point, a very interesting point. So I suppose you could argue that that is the point of input. Let's refine this ever so slightly, the point of user input for the purposes of this particular day, okay? But that's fantastic. I hadn't actually thought that is entering the system there, but it's user input, okay? It's like due to a user action rather than just some code action, okay? Thank you, Josh. You've given me some self-doubt for the rest of this talk. Humble. Okay. So let's move on. Direction of execution, the order in which code runs, okay? Again, we'll go back to our trusty call stack over here. The direction of execution is just simply that away, down. So from main to calculate, to find, to load. Cool? Everybody clear on those? I'm going to be using those quite a bit. So if you're not clear on them, throw a potato at me. Oh, no, wait, Matt's not here. It's fine. Cool. Well, I hope he's not here, him and his gun. Anyhow. Cool. Okay, so let's talk about gravity using these terms. In the physical world, you can't build something on top of nothing. That's why we either build scaffolding, like those brave souls are doing in that picture, or you build some sort of foundation so that you can build on top of it. You have to have something to build on top of. The conventional wisdom, the way this translates, in my theory, into the software world, is that you can't call something that doesn't exist. So I don't have something. If I try, I get a compile error. Nice red line, and great, I can't do that. because then I'm not making progress, right? So let's go back to the trusty call stack and look at what this might look like here. Well, where am I going to start? If I start at main, my calculate doesn't exist yet. If I start at calculate, my find doesn't exist yet. And I just carry on pushing all the way down to, oh, load. That's a great place to start. So I code that first, right? Who's done that? It can be repository.load.find. Like, oh, your arms are definitely not working now. Come on. Almost, maybe you start at calculate, maybe. But it's a common thing is people go, cool, what's my data going to look like? Okay, I need to get it from somewhere. And they start thinking about that. That's the first thing. And then they code find because they have a load to call. And then they code calculate because they have a find to call, and so on until they get to the point where they can go, yeah, I can execute it. And that's the 5 days later you go, I'm not going to watch F5. I'm going to get coffee before I look. Come back. Yeah, I rock. Or normally, oh, what went wrong? Okay, so we normally code against the direction of execution. And sure, this is an ideal situation, so sometimes you're a bit more erratic. You maybe start at the find, and then you go to the calculate, then go to the load, but you normally work your way back up to where you go, where the user input, Josh, user input is going to come from, user data. And by the way, if anybody else is wondering, I would class as no input, just a command line, call with no parameters. Is also being data because it's a command to say run the code. Okay, one interesting point is that when you do this, you start very far away from the point of input. And right now, that's just an interesting point. But what is the cost, you say? Why? Who cares? This is the way I do it. This is the way I think. It's always worked for me. That's great. And well, I mean, you're all here and you're getting paid still, so at some level that's true if you do it that way around. It does work, But what is the cost to it? Well, you need to kind of guess everything from load, find, and calculate, all the way to the point of input. And how many times, and I'm very guilty of this, you do your load, you do your find, you get a calculate, you're like, oh, I need that other field. Or, oh, I don't have this field yet. And you go along and you play around. And anybody done that? Okay, that's better. People are, yes, yeah, now you're being honest with me. And guessing is hard, time-consuming, and just plain open to mistakes. When you're sitting down and you have to do guessing on what you're going to write, I'm going to, in this case, write a command line app, and I need to load data off a file, but then I'm going to do call it. You're guessing a whole bunch of stuff. Method signatures, data payloads, all sorts of stuff you're busy guessing. And the greater the distance from the point of input, the greater the more guessing. Wow. Midnight slides! Anyhow, the greater the distance from the point of input, the greater the guessing, the more guessing you have to do, right? Clearly, I don't know which one I want to say. So, we don't like guessing is a bad thing because it's hard and open to mistakes. So what is the hidden option, Brendon? Well, what should I do differently? Well, you just flip that arrow around because we're currently doing this, so you code with the direction of execution. No, you say. That is impossible. Well, because I thought you were going to say that, but nobody stood up and screamed it at me, I've got some examples of how you might do that. So the first thing is to actually physically just code in that way. But the problem with this is you're going to code main, you're going to type calculate, and it's going to be a compile error for ages while you're busy coding some other stuff. And that's not really ideal. You can't get any feedback. It's like, oh, that's horrible. But you could do it. And then you could code the whole of your calculate and then the whole of your find and just code it this way around. But that's pretty similar to the other way that we were doing it. And it's got the same disadvantages, most of them. So the other way is to refactor in that direction. Now, some of you were in the room for the previous talk and how refactoring is a discipline and is hard, I know. But if you do have that discipline and you can rely on it, then you can start with main, get something working. And then when you discover your calculate function, you refactor that out, and then go to calculate function, work. Load the damn data from the file, I don't care, because we're in like short feedback cycles. Then when you find your find function, load that. Refactor that out, and so on and so forth, until you have, a decent looking code that makes sense. But again, that's like, yeah, that's okay. And we'll all write enterprise software here, right? We're all line of business guys writing massive systems with 1 billion interfaces or function signatures. So you all just write small apps, like mobile apps then. Well, you guys are lucky. It's not stressful to do the other way around. Anyhow, I'm just going to pretend you use interfaces. Okay, or some sort of abstraction. So the other one is abstract in the direction of execution. So you start your program and you're like, la da 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 da, ooh, I need to calculate something. So you make a calculator and you have a calculate method on it. And then you carry on. Notice no compile fail now. Like, I could push F5, but I probably need some instance of that calculator. So what you do is you go, always 0 calculator. It always returns 0, always 100. Doesn't matter. You have something that satisfies that particular abstraction in a very, very simple way, but you carry on coding. And the nice thing about this is I can push F5 at any point in time, and it will run. It's not going to load off the file system yet, but I can check the code I'm doing in the main. And I can get my learning out of it, which is great. And then when you're like ready, for the real world, real deal validator, midnight science, real deal calculator, calculate, you implement it. And then you carry on doing that. Then you might need a load. So if you want to use the repository pattern or one of the many data loading patterns, you put that there and you put a fake one, you carry on with that pattern. So that's another way of doing it. And since we all already have these horrendously large call stacks with thousands of interfaces in them, why not just do it this way around? Because the code we're writing supports that anyhow. Okay. So the hidden option, just to summarize, to deal with gravity, or that's hidden by gravity, is to start at the point of input and build in the direction of execution. It doesn't matter if you're abstracting, refactoring, or just plain coding, but just do it with the direction of execution, because if you don't, you're going to have to guess what's going to be calling the code you're writing now. And then you're going to have to guess what's calling that code. And you're going to have to guess what's calling that code. And eventually you'll get to the point where data comes in, you can go, let's check if it worked. Got coffee break. Well, that's what I do. I don't know. Like, I'm scared about pushing F5 well, I used to be scared about pushing F5 sometimes. I was trying to think of a way watching other people's talks not to make that particular situation awkward. I was like, oh, well, I'll just post. Okay. So hard to change. I've already kind of gone over this a little bit and explained why I think it's a thing that manifests in the software world. And it isn't a problem in the software world. But let's just go into it. So in the physical world, things are hard to change once they're built without destroying them. You can't uncarve a piece of wood. You can't move a wall without breaking it. You can't move a concrete slab with my lovely Creative Commons picture. It's the most time that I spent trying to prepare for this talk to find Creative Commons pictures. So the way this manifests in the software world is you're like, code is hard to change, so I have to build it perfectly. I have to build it right the first time. I have physically said those words. Anybody else said those words? You've got to build it right the first time. Okay. This audience is like either just 10% energy or 10% honesty. I'm going to go with energy, going with energy. Or you just haven't got to that point in your career. Watch out. Okay. So let's go back to our trusty call stack. What does this look like? Well, you may have guessed from the other one, but I'm going to build all of that. I'm going to do the most awesome file loading thing ever. It can process XML, CSV, JSON, all of it. Because I don't know what I'm going to get, and I don't know what my caller's going to want, and all of it. And it's going to have all the bells and whistles. Then I'm going to do the same here, and the same here. I'm going to put. Nobody wanted to hear that amplified. Okay. And then eventually I get here. And now I can actually start using all of that stuff that I built completely. Oh, so what, Brendon? So what, who cares? It's worked for me ages. Yes, maybe it has, but what's the cost? Well, you risk building unneeded or the incorrect things there. And I refer back to the joke about I was going to load process XML, CSV, JSON, da, da, da. Or you build it all and you at your point of input, your web service, and you go, that's weird, it doesn't work. Oh, I'm not passing in that field. Where do I get that field from? I wish I knew that when I started. You're like, no, I have to rethink how I've structured the whole thing. So that's a big risk, and I've done it so many times in my career, and I'm guessing you guys have too. I thought I saw a hand, sorry. Another, in my books, the more severe one is that it takes a really long time before you can get feedback. I mean, when you do it this way around, when you build the whole of the load, the whole of the find, the whole of the calculate, Somebody comes up to you and says, hey, can I see how's it going? No, I'm doing the DB. I've said that as well. Or no, it's not ready yet. We're building framework. 6 months later, we're still building framework. It'll be awesome. We can make it do anything, I promise. So you can't get feedback on the work you're doing. You can't check if it's right. You can't show anybody. You don't even know if it's right. It's awesome in your head, but is it right? So what's the hidden option? What do we do? Sorry, I thought it was my timer to tell me I'm almost finished. Okay, well, that way that I've just shown is kind of building all of one thing, then all of the other, then all of the other. The hidden option is to build it this way. Now, what do I mean by that? I mean build a little bit all the way through, and then build a little bit all the way through again. So let's see what that will look like. So you start at the point of input, and you iterate in the direction of execution, right? So you'll start with your main, you code a little bit, and you build only as much as you need to know what to code next. So you go along, and you might go, cool, okay, I'm going to have some input from my console app that args will have, I don't know, a JSON blob, and it will have name on it. Bam, you've got something to work with. You might also have in your mind or your analysis or your design or whatever, like 40 fields, but you've got something with one field, and you go, great, okay. I know what to do next. I can pump it into this. Let's just say name and age, because you don't calculate anything on name. So great, I can do something. My calculator is just on age, so I'm going to go start writing the calculate. And then, I need to find by name. Cool. And you do that, and then you go, cool, I can load a dumb file. I'll just pretend it's going to be CSV, and you recode that. And then you do it again, and again, and again. You add more fields, you learn more. I think I've got benefits in here. I forgot my next slide, so excuse me. Anyhow, so you just carry on doing that until you've catered for your analysis or the problem you're trying to solve, and then you stop. So just to summarize there, you start at the point of inputs and you iterate. You go over and over and over again. And the really cool thing about that is that there's hard to change. There's two aspects of hard to change. I discussed how in the software world, the thinking is the one that takes up most of the time, not the actual changing. And by doing this, you're amplifying your learning. You're going all the way through and finding any of the problems that you could or would encounter at each step. So you're actively trying to feed information into that decision-making process. That is the thing that takes most of the time when you want to change in software. So just to give a high-level review of those two things, I've kind of drawn a very rough little arrowy thing. So gravity is going to encourage you to build against the direction of execution. That's going to lengthen your feedback loops because you're far away from your point of input. It's going to encourage you to start far away from your point of input. I just predicted this. That's like I made these slides, Anyhow, and starting far away from the point of input means you're going to be guessing a lot. Hard to change means you're going to be building a whole lot of what you just guessed, and it's going to lengthen your feedback loops enormously. Whereas, if you start at the point of, I see phones in the air, take the photos. Go ahead. I saw some panicked people in that keynote. They're like, oh, that was lagging. Only if I had an S9. I see a few more. Cool beans. Okay, it is video, so I'm going to look like a clown. You can get it afterwards, but anyhow. So whereas when you start from the point of input, and that's going to shorten your feedback loops because you're starting from the point of input. So by definition, you can start inputting information into your system. It's going to encourage you to build in the direction of execution, which is going to reduce or remove the need completely for you to guess things. And when you're only building as much as you need, you're now going to stop guessing because you're going to go to the next step and get the information and the learning from that next step, which is going to shorten your feedback cycles because you can push your 5, show the business user, show your team lead, get him off your case. No, I'm joking. I'm a team lead. Team leads are great people. So please build the roof first. And in this case, I've actually got some 3 rules, and they do a better job of what I was about to say. So the 3 rules of building the roof first are this. First, start at the point of input that adds the most value. And this is really important, to add the most value. If you're about to embark on a system that's got a super fancy algorithm. And the entire system is not viable if that algorithm cannot be achieved. The point of input that's most valuable to you at that point in time is the public API for that algorithm. You're going to, even though it's not a UI, it's not an HTTP call, all those things I said before, it's the point of input, it's the API for that algorithm. So what you're going to do, you're going to write a unit test, or if you really hate those, you're going to write a little console app that's going to call it directly, and then from that public API of that algorithm, you go. And you then build in the direction of execution. And only build enough to know what to build next. So those are the three, I won't call them laws, but rules that I follow to build the roof first. And I just want to finish off by saying, I really hope that next time you sit down in front of your keyboard, or if you're pairing or mobbing, telling the other people about this, because they weren't lucky enough to come to DevConf, think about the order in which you're writing the software. And you can think of it in terms of point of input and direction of execution. I spent a lot of time trying to find two simple terms that most developers understand that you'll be able to talk in concrete terms to other people about. So you can say, we are far away from the point of input. We are going to need to guess a lot of stuff, and it's very risky. Can we rather move closer? Because everything's about having a good end goal to work towards, and then getting as far as you can towards that goal. And if it's just one step, if you can get one hop in your call stack closer when you're pairing with somebody, that's a win. So really, just sit down, and next time you're about to type something, or you're sitting with somebody and you're about to type something, think about the order in which you're writing it and the costs to that particular order, or the disadvantages and advantages using point of input and direction of execution. And for those people who completely rejected the building metaphor, anybody? Oh, and I don't know if it's like falling off arms or fear. Remember Pete's talk, courage? Yes? Yes? Okay, we'll just go, everybody agrees. But if you didn't want to admit to it, that's fine. Then just ask what it's hiding from you. And to do that, remember a metaphor at its core is experiencing or reasoning about one thing in terms of another. And the ability to do that means that something is necessarily going to be hidden about that thing you're reasoning about. So just ask yourself, what is obvious in this metaphor I'm using that manifests in the concept I'm busy reasoning about? And does it actually exist there? Is it a real thing? Is there a good mapping? Or is it just like gravity where code doesn't fall through the bottom of files? Yeah. Cool. Thank you. And any questions? Oh, okay. Yes. I don't know if we're doing a question mic in this room, or am I just going to repeat the question? Okay, I'm going to repeat the question.
Cool. So, is it point of input, or would you say it's point of risk almost? Because you could technically have the inputs being easier, but the point of risk could be, for instance, a really difficult communication between two systems or something like that, or some weird interface. So is it more point of risk or point of input, or do we see input as thought input?
So I try to keep it as, okay, so the question is the point of input the point of risk rather than always being input from a user, like a button click or something? Is that a good summary? Yeah. Okay, so that is why I've added the point of input that adds the most value. Because you could just waste so much time coding a massive amounts of, well, hopefully not a mass because you're working with coding just enough, and I don't know, doing 20 hops in your call stack and then getting to your algorithm. And that's maybe a day or two, because you had to set up Webpack. You know? And I was like, oh, yeah. Anyhow, so you get there after 2 days, and you're like, this is not possible. I just wasted 2 days of my life. So I would say you don't always have to choose a point. Don't always choose a point. You don't have to choose a point that's going to be, that is user input, but it's going to normally have user input flowing through it. And if it's more important than knowing that the point of input from the user side is going to work, start there, but try to create a repeatable test in some way. Like a unit test is great. And then you're kind of emulating input in different scenarios, but you're still starting from the public API of that algorithm and then doing the iteration. Because even on algorithms, unless they're in in some book, I don't know, you're probably going to have to learn anyhow. And you're going to want to amplify learning, shorten feedback cycles, so you can still do it there. So don't go away and say, this guy at DevConf said we have to code everything from the button click. That's not necessarily the case. It's the point of input that adds the most value, and sometimes it's the most value, the value to the developer is higher than the value to the client at that point. Because you're like, I need to make sure I can do this. And if I can't do this, I can't add value to my client. So I'm going to start there, write some unit tests, iterate, woohoo! Okay, but then you've got to have the discipline to go, pause, I've done enough, it's possible. Now I need to start reevaluating whether or not the value is higher somewhere else, and then iterating from there. Did I answer your question? Yay! There was more arms flailing. I'll get to you now. So I'm going to do this side, and then this side, and this side. I think it's the only fair way.
Would following sort of the principles of TDD not encourage a style like
That is a good question. The question is, would following the principles of TDD not necessarily naturally guide you towards this style of developing? Not necessarily. So I would say, depending on your take of TDD, right? I've done TDD, and I've seen TDD written where somebody imagines and thinks about the entire call stack, like invents the implementation, then write tests so that they can write that implementation. So they might not necessarily pick the point of most valuable input. They'll just start at the damn core and work their way up anyhow, but they're still TDDing. So in that way, it's reducing the risk of that F5 risk. But that's the only risk it's reducing. You're not reducing, am I building the right thing? Am I building unnecessary things? So it mitigates it slightly, but it doesn't necessarily guide you to this exact thing because there's extra thinking here. Where am I adding the most value? But you're right, it helps with the direction of execution. So you're going to code, you might start at a funny place, but at least wherever you're starting from, you kind of iterate there, but then you kind of move over here, and there's not a broader context to, I should be trying to code completely in the direction of execution. So now back to this side. Yes?
So, I think the opposite of that house principle really
Yes?
is like a multiplier. So imagine that you're not building software for a client. Imagine you're building an internal API.
Mm-hmm.
And you need to provide like whatever people might call it. So let's say like the example I have is like a sound API.
Mm-hmm.
You need to be able to like play, stop. But then if you did it this way, which I think is the right way, you'd go, okay, I either play and I either stop and I'll see if someone needs it.
No, that's a good question. Okay, so, yeah. So I'm going to summarize the question. So clearly back-end services developer right there. So if you're just purely coding an API, and I'm needed now essentially, I think what you're saying is I need to add stuff that I'm not even going to use. It's for somebody else, and the sound API is an example, so I know I'm going to add play stop, blah, 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 blah. Right, so I would say that, remember I'm saying this is when you sit down and get your computer. So you have a business requirement that you know you're going to need to solve, and that's come from elsewhere in the business, and people have put thinking into that. So there's no doubt that you're still going to need to code those 10 things. But if you code with the direction of execution, chances are that you're going to learn more things about the problem you're solving, where if you do it the opposite way around. So you might decide, okay, I'm going to do a sound, you've probably downloaded one, but like it's probably a JavaScript framework that was invented yesterday. Exactly. But I mean, imagine you were coding the actual sound algorithm itself. You might you start with that and go, okay, well, I'm going to need to make this thing be able to do a play, pause, stop, and then you might do the next level up, and the next level up, eventually get your HTTP. Doing it that way around, there's still a whole bunch of risk because you're guessing how that thing's going to be called by the thing that calls that the HTTP calls. So by doing it the other way around, you're going to help get the public API of your sound library more accurate from the beginning without basically building unnecessary stuff and with unnecessary thinking, even though you're still going to code those 5, 6 functions, you're still also going to be able to play immediately. Where if you do everything first over here, you can't even do that. You can't even go to your browser and type play. Did it work? Yes. You know, so you're still shortening the feedback loops, even though you know what you're building. That's what I'm saying. Don't try fight the requirements analysis. Don't try change that stuff. It's how can you make yourself better by reducing the guessing, shortening the feedback cycles, and reducing the risk of just building fun stuff that you think would be fantastically awesome that nobody needs. And every time somebody asks how much more time, you say 2 days. But it was 2 days 2 days ago. I know. Yay. So does that kind of answer your question? It's yeah. Yes. Precisely. Or an integration unit test or something. And the nice thing about that is also you're going to get immediate feedback on how it's going to be to use your API. Because every time I've defined thought about a castle in the sky and then built it, as soon as somebody had to use that, they were like, this is the worst. And I go, oh, no, but it's the best in my head. You know, and by starting from the outside and actually consuming it, you will feel that pain first. So it applies to even embedded developers. If you have embedded developers here, you're going to have sensor input. You're going to have, whether it's like gyroscope input or input from a machine or something, start there. Same thing as your question, where it's like, it's an API. It's essentially, there's no user interface. And now I've already answered your question. Yay! Okay, any more questions this side? Okay, any more non-trolling questions this side? He trolls me so hard, I just had to be sure. Okay.
So, no, I don't. I'm just seeking some clarity on your point one. Starting at the point of input, is that to the developer, to the business? To the
Good question. Good question. So it's the point of input that adds the most value. Is it to the business? Who is the value add to? How you like? Do I always measure it against the developer? Yeah. Okay. So I would say that favor like your favor the users or the business, and then it might very well get to the point where it's more important for you. There's a point of input that's more important for you as a developer because you need to ensure something is technically achievable at that point in time, because you cannot add the business value if you don't know that.
You don't say it's the problem. The problem will encompass the technical aspect.
Yes. But I mean, if you always just want to add value, if you always pick one based on the value added to you, then you're going to be starting sort of mid-level through your call stack probably, and you're going to miss that learning and do the guessing on how your little external plugins are going to be calling your stuff, and you're going to just build the wrong stuff. So great question, thank you. Did it answer your question? Mostly, okay. Yes?
If I was to summarize what you're trying to do, it's to reduce risk and increase your
Yes. However, what I wanted to point out more importantly is that the metaphor that you use in this industry is hiding something from you that increases the risk in guessing. And you don't even know it. You don't even know it's an option. So the benefits are it shortens your feedback loops. If you do the hidden option, it shortens your feedback loops, reduces risk, reduces guessing. But the reason why you're taking those risks without knowing it, guessing without knowing it, is because you're using the building metaphor, and I'm not going to try to change that, just carry on using it, it's fine. I've tried to do that in the past and I failed. Because you're using a metaphor that's hiding aspects about what you're doing, and that's the more important message, is that you've got to go, and it applies to anything. It can apply to software dev, to things you do elsewhere, but in software dev it's particularly bad. When people code against the direction of execution, stupid amounts of risk. But yes, I mean the benefits, I would say your question, the summary of the benefits was accurate. So that you get reduced risk, less guessing, shorter feedback cycles, but you didn't know that you could get it. And I'm telling you why you could get it, and the options for achieving it that were probably hidden. Okay, I think I did that side many times, this side. Okay, all questioned out. Yes? Yes.
It seems like everything is starting from the foundation. Why did you
Well, I'm defining the roof as the point of input, the point of user input. So it's interesting because we've been classically trained, do your ERD. Do your, think about your data structure first. But the thing is, nobody runs a data structure A SQL Server runs a data structure, but no user runs a data structure. So I would imagine that to be what would translate through to the foundation if you had to map the metaphor one-to-one, is that your storage mechanism or your core. Who here has gone, I'm going to do CQRS, I'll build the whole CQRS framework first. That's scaffolding. You're building scaffolding, essentially. And I've done it. So many people have done it. But you're not building the foundation. You're just building the stuff that you're going to build that's going to support the actual value-adding code. So the point of input is the roof. I maybe should have had a slide about that. Thanks for the notes, guys. And thanks for paying to come give me the notes. Yeah. Cool. Good question, though. Yes, yes, although I challenge you to find a Creative Commons one. Yeah, and I got a lot of mine off there, and also pxhere.com is also quite nice. Cool, guys. Any more questions? I think I'm probably eating into other people's time or something, so you can come talk to me afterwards if you want. Oh, it's a snack time. I'm literally...